Okay, so we're going to continue with operations with scientific notation. This video is going to focus on multiplication. Just like last video, I want to start with a few examples to lead us up into the topic. This first one, x times x, that gets into the basic definition of exponents and why we use them. Instead of doing repeated multiplication, if it's x times x, the same variable, you can simplify that to x squared. With this second one, we already have exponents, but these powers, they have the same base of x. So if you're multiplying powers with the same base, we already know that rule, but I just want to show you again where it comes from. We have x times x, and we're multiplying it by another x times x times x. Multiplication, we have repeated multiplication. X times x times x times x times x. We can simplify that, x to the fifth power. If you remember that rule, the law of exponents, when you're multiplying powers with the same base, you can just add their exponents. So x to the, 2 plus 3 gives you 5, so x to the fifth power. This next example, 2x cubed times 3x to the fifth power. So if we write this out, 2 times x times x times x times 3 times x times x times x times x times x. With multiplication, you can reorder things. That's a beautiful thing about multiplication. So instead of having this 3 multiplied in the middle there, I'm going to move it to be 2 times 3. 2 times 3 times x 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 times x. 2 times 3 equals 6. How many x's do we have being multiplied by itself? 8. So if you refer back to our original problem, 2x cubed times 3x to the fifth, well, you can multiply the coefficients, and when you're multiplying these powers, they have the same base, so you can just add their exponents. 3 plus 5 gives you that exponent of 8. So if you're multiplying two terms, they both have the same base with the power right here. You can multiply their coefficients and then add their exponents. So we go to this next example. There's no variables, but we still have a power 10 to the fifth and another power 10 to the second power. Notice they both have the same base of 10. So when we're multiplying, you can multiply the coefficients. 4 times 2 and then you're multiplying that by the power 10 to the 5 plus 2. So to simplify that, 4 times 2 equals 8. Our power, the base stays the same, but our exponents are added, so it's to the 7th power. So we multiplied our coefficients, 4 times 2 to get 8. And then our powers have the same base, so all we have to do is add the exponents. 5 plus 2 gives us 7. Alright, that brings us into our guided notes for the day. When numbers in scientific notation are multiplied, only the number, let's call it the coefficient, only the coefficient is multiplied. So when numbers in scientific notation are multiplied, only the coefficient is multiplied. The exponents are added. Because scientific notation is beautiful, the base is always 10. You We pretty much guarantee that with scientific notation. The base here is always going to be 10. So all you need to do, add those exponents. 3 plus 4 over here will give you your answer of the 7th power. Multiply those coefficients. 2 times 4 gives you your coefficient of 8. So you're multiplying your coefficients and you're adding your exponents. And now you have your new number in scientific notation. Let's move on to a couple examples we'll do together. So scientific notation, 3.25 times 10 to the third power, multiplied by 2.0 times 10 to the third power. So 3.25, going to multiply that by 2.0. And then we've got our times 10 to the 3 plus 3. We're going to multiply our coefficients. We're going to add those exponents. So you get your final answer, 6.5 times 10 to the 6th power. 3.25 times 2 gives you 6.5. And then 3 plus 3 gives you your power of 6. Want to double check, is this scientific notation? Well, yeah, we've only got one number on the left-hand side of the decimal. And we've got a power of 6, so we should be good to go. Next example, multiplying our coefficients, 5.25 times 4. And then you want to add those exponents. So times 10 to the 4 plus 7. Alright. So 5.25 times 4 should give you 21, or 21.0. With scientific notation, you generally want to include at least one number after the decimal point, so 21.0 times 10 to the 11th power. Is this complete scientific notation? Let's check it out. So we've got a base of 10, a power of 11. Cool. How many numbers do we have to the left-hand side of this decimal? Well, in this case, we've got 2, 21. So we have to change this a little bit. In order for 21 to be in scientific notation, only one number can be on the left-hand side of the decimal. So 2.1. But now, you can't just change the decimal point. Since we moved it to the left, we also have to increase our power by 1. So 21 times 10 to the 11th power is the same thing as saying 2.1 times 10 to the 12th power. We move the decimal point 1 to the left, therefore we have to increase our power by 1. You should be pretty familiar with that rule, but let me just write it again. When moving the decimal one place to the left, increase the exponent by 1. It's a beautiful thing about scientific notation. Once you kind of get the hang of it, understand it, it's pretty easy, pretty straightforward. You're moving the decimal point one place. If you're moving it to the left, that means you're going to increase the exponent of your power. Alright, so you should have a few example questions on the back of your guided notes. Do those as practice. Let me know if you have any questions. But hopefully after those you feel pretty good about multiplying scientific notation. Sweet. Enjoy.